On these next two examples, what we want to do is we're given a triangle and our goal is to find some indicated angle based on this triangle. So on this first one, based on where the angle is, I'm going to go ahead and label the sides of the triangle. So this is based on the 9 is an adjacent side to the theta. So I'm going to say that's the adjacent. And then 12 is across the triangle from the right angle. So I'm going to refer to that as the hypotenuse as we write this out. And now what we do is we think SohCahToa. All right, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. Being that ours involves the adjacent and the hypotenuse, I'm going to use cosine. So I can say cosine of theta is going to equal this ratio of the adjacent 9 over the hypotenuse 12. With just a little bit of reducing down, what we can do is we can say, well, 9 over 12 is equivalent to 3 over 4. And now what we'd like to do is cosine, we have cosine of theta. So theta is inside of this function, the cosine function. We'd like to get theta, our angle, out of this. So what I'm going to do is I'm going to apply cosine inverse to both sides. This is also referred to as arccosine. So cosine inverse applied to the left-hand side, and then cosine inverse or arccosine applied to the right-hand side. All right, so cosine inverse of 3/4. And then on the left-hand side, what's going to happen is these are inverses of one another. So we're going to be left with theta on the left-hand side. And on the right-hand side, that's an exact answer, I guess, cosine inverse of 3 over 4. Let's go ahead and get an approximation for this by putting it into our calculator. I'm going to go ahead and say 0.7227 as our result. All right, very similarly on this next triangle, let's work through this in a very similar fashion. This one's going to be a little bit different in that we're given different sides of our triangle. This time we have theta down here in the bottom left. So we would refer to this as the opposite side over there where the 6 is, and the 10 is going to be the hypotenuse because it's across from the right angle. So in this case, being that we have the opposite side and the hypotenuse given to us, I'm going to use sine of theta is going to equal the opposite over the hypotenuse. Or we could say sine of theta is going to equal, with just a little reducing down, 3 over 5. All right, from here, let's go ahead and very similarly to the first one, let's apply the sine inverse to both sides. So sine inverse of sine of theta is going to equal sine inverse of 3 over 5. So we get theta on the left-hand side. It's going to be approximately, as we put it into our calculator, 0.6435. And that's basically it. So you want to take your time, think SohCahToa, pick out the correct sine, cosine, or tangent, trigonometric function to set up your ratio, and then apply a sine inverse or a cosine inverse, or this could be tangent inverse to both sides, to get your angle theta. All right, hope this helps out. Good luck.